So, I think it's time to get started finally. Let's see what's going on here. Ah, hello everybody. Today streaming from an alternate location again. Welcome to the whatever Yocto live coding session. Going to real hardware, try number 2. And I'll be probably looking most of the time not at you, but right here, because today I've got a multi-head setup, and so I can watch and check if the connection is all right while doing content at the same time. So a little bit of housekeeping first. This does not bring any new content in comparison to Tuesday, or at least nothing that I did not intend to cover on Tuesday. We'll be talking about running a custom built image on a Beaglebone Black and digress a little bit in what BSPs are, what BSPs do, um, and have a little peek at WIC, what its part in the whole process is. The peek into WIC will be really short, probably because I just don't have a clue how it works exactly anyways. So it's just like more, I know it's there, I know what its functionality is, and if you need more information, then you have two options. Read the wonderful manual on the Yocto project homepage, which you should be doing anyways, and get in touch with us. So I'll be taking as many questions as possible in any way right through the Twitch chat if you have signed up for Twitch. If you have not signed up for Twitch, that's not a problem either. Just scroll down. There's a direct link to our seed channel on Freenode, #Yocto on Freenode. Just click it. It will take you to the web interface. Pick a username and say hello to us. There's no login. There's no registration. There's no nothing. Just click it and say hello. So, okay, I think it's time to get started. Where is my terminal? Here is my terminal. Okay, I'm a bit confused still with all the different screens. This is not my usual setup for streaming, but I think we'll manage to get through it. Yes, some more housekeeping. Hope some of you were there in Lyon at the Yocto Project Summit. If so, I hope you said hello to me. A couple of folks did. I'm glad there's so many people enjoying what I'm doing. Thank you very much for also letting us know. There's also some guy that wanted to talk to me about the stream in the front of the Yocto booth, and I just like told him to come back in 10 minutes because we were actually just discussing how to proceed with the stream. So it was a rather important discussion, and we didn't manage to talk then for the whole rest of the conference. So really sorry if that was you. If you are seeing that, I apologize. Just try to reach out for us through the mailing list, through Twitch, through IRC, whatever. We'll sure um, be able to connect. Okay, so time to get started. If you want to build something for real hardware, you usually need a BSP. BSP, as you can see here, stands for Board Support Package. And that already explains a lot of what it's meant to do. It's meant to support running the whole open embedded Yocto Pocky thing on a specific board. It's important to understand that one thing first. It's not like doing magic and giving you a whole full-blown development setup or anything. It's just in its core functionality. It means like bring the necessary pieces for making an image run on a specific board. And in the most cases, this means like bring me a bootloader in the majority of cases for ARM boards, this will be U-boot. For x86, I'm not really sure. Probably something EFI by these days, but that's not my strong side. And usually bring a kernel, or at least a kernel config if the board is already sufficiently supported in mainline, and make known that this combination of bootloader and kernel/config can run on the board in question that you have. I'll be using the Beaglebone Black here, with which is an ARM v7 Cortex A8. This is the original incarnation still, with only 2 gigs of eMMC, and you can already see one specific thing here. This, you can see the adapter, probably it's rather small. This is like a cheapo TTL2 to serial adapter I got off Amazon for 2 or 3 euros. If you're doing embedded development and you're going to hardware, you're doing board support, you will almost certainly want some form of serial terminal access. If you can only reach out for the terminal of your board when the kernel and SSH are already up, then you're probably just outright doomed. So if you're doing something like this, make sure you get real low-level access to some form of serial terminal so you can access the bootloader. Okay, so I've been talking about the BSP. I hopefully have one here. These are the things that we're going to use. Pocky, as everybody knows, Meta TI, because the system on a chip on the Beaglebone Black comes from TI. It's officially supported through the Meta TI layer, which is also hosted on git.yoctoproject.org/meta-ti.git, or without .git, no idea. Google it. And MetaTinker, which is just like a demonstration layer, I'll be using hopefully later to show you a little twist. Okay, so what are the things you usually should have to do in order to use a BSP? You should download it, obviously, as I already have for MetaTI. You will totally want to make sure that the branch of the BSP matches the rest of the distribution that you're using. So if you are on Warrior, on Pocky, then make sure that your BSP is also on Warrior. Same goes for THUD, same goes for SUSE, same goes for about everything. Just make always sure that your layer revisions match. Sometimes the BSPs do not match the release of Pocky that you want to use. In that case, look at the documentation, which you also should do every time, and find out if it's intentional. So that this specific release is actually not supported. In that case, either pick another Pocky release or just try your luck. Or sometimes the documentation states that even if there's no branch, then it should work, or else. We will also have a small peek at the documentation here for one thing, because BSPs can depend on several things. Usually, if they are like well crafted, they should hopefully only depend on Open Embedded Core. But sometimes they need more arcane magic. And as for any other layer that you're using, always make sure you get all the whole dependencies. And I actually hoped that I would find something for the Beaglebone Black, but we will see. Okay, so I downloaded it. TI, master. Let's just check what layers are there. You can see that there's not yet even releases for Warrior and Zeus, so that's why I'm stuck on Master for today. Okay, I got the BSP layer, and I intentionally picked a branch. Those are important things. What's the other important thing that you should have to do? You should have to pick the machine. So again, we look at the BSP. Where are the machines? The machines are in conf machine. This is a canonical place. Any machine configuration file that's meant to work with Open Embedded or Yocto in general has to be at that subdirectory hierarchy in a layer. Okay? So here it is, the Beaglebone. We'll have a peek. This is a classic machine configuration file. It defines a bunch of kernel device trees for the several revisions that be or incarnations variants that the Beaglebone has. It defines that kernel device tree and kernel Z image have to go into the image. That makes sense given the boot strategy of the board. And it defines a WKS file, a WIC kickstart file. We will look at this in the end. It also defines what U-boot we need for the boot strategy and the image FS types. Why does this go into the machine configuration file? Because especially when we're talking about ARM, then the boot strategies are massively different between the SoCs. So we have SoCs that can boot something right directly off an SD card. Some can boot out of SPI connected flash, from SPI quad SPI connected NAND or NOR. Some even from SATA, all those things. And there's really nothing generic. So this is basically part of making something boot for this specific machine, and that's why it goes into the machine configuration file. Little more skimming what's going on here. Nothing of real importance. Okay. So yes, we want to use that very machine configuration file. How do we do it? Conf local.conf again, and here we go. We set machine to the Beaglebone. This means we want to build not for QEMU ARM, but for the Beaglebone today. Let's just check what else is going on here. Hopefully, okay, I'm fine with that. So bitbake core image minimal. So much talking. BSPs need a lot of explanations. That's why I've been talking so much, more than probably in the beginning of any other live coding session so far. And you're all so quiet. There's nothing happening on the chat. There's nothing happening on IRC. If in any case, just say hello. Okay? I don't have any glitter stickers anymore. It's also rather hard to get them through through Twitch, but feel like you get one if you say hello. Okay? So image is basically built because I prepared it. Of course, it's rather boring to watch my build server work for like an hour or two. So again, we got to look what's going on. Temp glibc, deploy images, Beaglebone. There's a lot of things that I would expect to make my machine boot now. And I see that this is really like a little bit too short to properly read it. Let's do it like this. Temp deploy images Beaglebone. These are the things that are of importance. What you can see here is that all the really necessary artifacts, including U-boot and the C image and the device tree and the modules, are also there and can be accessed separately, but you usually don't want this. What you usually want to use is the WIC XC file. Why? WIC is the magic that takes everything, and if the machine supports it, of course, and pours it into a form that the machine can directly boot. Why? Or let's just explain a small nerd joke. What is WIC? WIC is the Open Embedded Image Creator. So how does this go together? If you look at this, this seriously does not show Open Embedded anywhere, but if you take the expression Open Embedded Image Creator, you make an acronym out of it, and you pronounce this, then it goes like WIC, which sounds basically funny, WIC. And if you want to make it more easy to pronounce, then they call it WIC. So here you go. Richard asks if glitter sticker emojis exist. Actually, they do. And we need your help for this. If we got enough people following us and enough people streaming, and then we can go like for the next stage on Twitch, and then we can have glitter sticker emojis. And I'm not kidding you. Seriously, then we can have like a Yocto logo and a glitter sticker logo. Yeah, we get emotes if we are famous on Twitch. So anybody who's watching this later on YouTube, make us famous in Twitch and get a glitter sticker emoji. So I digressed. My English is bad. Okay, we want to look at the WIC XC. Why WIC XC? It's just compressed after use, after creation. A little more detailed look at it. Deploy images, Beaglebone, core, image minimal, whatever. What more even ever? rootfs, quick exit. I hope you don't mind the timestamp. This is all from Tuesday. You can see the image or the WIC, the compressed image that we are seeing is like 6.5 megs. Seriously, 6.5 megabytes, including bootloader and kernel. And this is like that tiny difference in comparison to the gigabyte, 1.5 gigabyte standard image on beaglebone.org. So, first conclusion, you can make really small handcrafted images for your boards, but it takes you time. You have to get your head around all the BSP and Yocto stuff, but you are rewarded with an incredible amount of power. But if you're just like tinkering from your one-off board, use the custom, no, the standard Debian image for your board. It's usually way easier. Okay, so how do we use this? I will not demonstrate this in this terminal because it requires me to do some magic copying it from the build server to my machine, and then to the specific board. The only thing that I'm gonna tell you is that you usually do this by DD for a Beaglebone and for a lot of other images too, or XCCAT, because the image is compressed. So you usually do like something XCCAT temp deploy images Beaglebone core image yada WIC XC, and here goes your whatever. Okay, so I'll do this right off screen in a couple of minutes. Where Josef WIC X. Let me check where my SD card is. Okay, my SD card is around. XC cat core image minimal to def FDA. I shall use $_ to append to whatever previous command. My bash foo is really weak. I am no super nerd, and I don't know any of the hardcore magic. So you probably know a lot more than I do. I'm just the one that takes his time to explain all this. So if that makes sense, just maybe like do a short explanation into Twitch chat, and then I'll learn something again. Something to okay. Blah 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 blah. This is just like writing the image to my micro SD card. Sync. Now I'm plugging it into the board, and this is from a previous boot I did during my preparation. So you can see I'm now plugging it in, and hopefully the board starts doing funny things. Starting kernel, it runs off. Funny things, even more funny things. Okay, it probably won't find anything on DHCP. And here we are. This is an image that we built, and if we look at it, yes, uncompressed, it's like 10.6 megabytes. This is pretty okay for a non hand optimized image that just boots up a relatively modern ARMv7 board. Don't you agree? I think that's pretty fine. So, what shall we do next? Next thing is, shall we go looking at the BSP for some more time, or on some small modifications to the image? I'll give you like 10 seconds to vote. Dum 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 do 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 dum 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 dum. Okay, so no votes, but hello Joseph. Yeah, hello Gerenia too. So then I'd say we do first stage is a little modification, a specific image from the BSP into the image. Boah, sure, we can give it a try. We can give it a try. Let's see what the BSP has. Okay, what's there? Recipes BSP. Okay, there's a lot of stuff. No idea whatever of these things works for the there's something nice. RWMem, for example. Let's have a look at this. This is something you often will want to use during board bring up if you don't even have drivers for your for your board, then you will probably want something to poke the memory directly. And is this fine for you? Is this fine for you if we um, for demonstration changing the U-boot config? I would rather not do this because I will like break it. Okay. We will have a peek at U-boot right now, but I would prefer not to tinker with it because we will end up with a non-booting board. I'm pretty sure that I won't manage to get it right in the session. I don't even find it at the moment here. Recipes TI. Where is U-boot? Where is U-boot? Recipes kernel. There's only Linux. Let's look at this as a small part to it. Okay. Geranium says BSPs are board specific. Yeah, that's what they usually should be. Is there any reason for the question? Did I give the impression that this was in some way not board specific? So this is, for example, the Linux setups that TI provides for this, and so we scroll down for a little, and we hopefully will see that this, for example, allows a specific machine. Okay, there's a boatload of magic going on here, and no compatible machine being set. This makes it rather meh. Let's see whether if there's something compatible being set. Compatible machine. Here, for example, this is something that you can often see in a BSP, hardware specific software that where the recipe enables them only for a specific machine. The things we have here are like only for the keystone, only for other boards that I don't know, and even more other boards that I don't know. So this is really something common. And yes, I also expected U-boot to be in recipes BSP. That's where it usually is meant to go. So I'm surprised it's not there. Which brings us to the core discussion item on BSPs. BSPs should do one thing and do one thing well. The one thing that they should do well is make the board boot. Bring a bootloader, bring a kernel, and bring drivers that are in some way related to the board. They shall not bring like a lot of demonstration applications. Some BSP vendors do this, like, hey, this is the board that we sold you, and there's a lot of cool stuff that you can do with this board. So we show you this super shiny application, and so you don't miss it. We just pack it into the BSP. This is not cool. This is seriously not cool, because everybody who just wants like to get your bootloader also implicitly gets cluttered with the infrastructure to build your demo application. So if you're a board vendor and you're listening to this right now, it would be really nice if you make two layers, like a BSP layer that makes your board boot, and a demonstration layer that tells or shows your customers how to make use of the more fancy features that your board has. Okay, so we're already half into the session. It's time for beer. As usual, as you all know, it's always time for beer during this session. This is important. Skull. So, even more BSP discussion. There's good and bad things to be said about this particular MetaTI BSP. It's well crafted in the meaning that I can just download it and I can just edit, set the machine, and it gives me a booting image. This is cool. This is how it's meant to be. It does not require me to download and install any other software beyond what I usually need for Open Embedded. It does not tell me set this distribution, set this image feature or whatever. I just can like pull the machine and it boots. This is good. I know that the maintainer of this specific layer, it's Dennis. So Dennis, good job here. What I have to criticize, obviously just like coming from this small demonstration, I can't find U-boot because it's not in the canonical place. I expect it to be in recipes BSP. Seriously, if it's not there, no good. And it obviously includes an amount, however not a big amount, of demonstration and bling. I think it's okay as it doesn't cause me any headaches already. Generally, one would say it's not exactly optimal, okay? But nobody's perfect. I think we can agree on MetaTI being a mostly well-maintained layer. So, as a demonstration on machine and other things not clashing, this is why I prepared MetaTinker. You can build distroless. I think I have talked about this during the image machine distro session. And so when a machine is well constructed, I should be able to switch out the distribution for no good reason, just because I want to, and the machine should still work with whatever settings I think should be there. And that's what we want to do right now. We will look at MetaTinker. Do we have tree installed here? Too bad. If we look at MetaTinker, this is really small. You can see that it actually brings only one distribution, tinker.conf, which does one of my personally very favorite modifications. It switches out sysvinit for systemd. So if Dennis and his helpers, contributors, minions, gnomes, bosses, whatever did a good job, I should be able to just drop in this distribution and rebuild, and then the Beaglebone should start up with systemd instead of sys5init, okay? This is how it's meant to be. Let's give it a try. Local.conf, distro, tinker. It's tinker, not tinder, okay? This is all like for all audiences. If you're like 6 years old and can build something for your Beaglebone Black, I'm supportive. Okay? Tinker, not Tinder. Bitbag core image minimal. Again, time to drink. The warning up there told me that there is no recipe in MetaTinker, which is actually correct. I told you that. So, one more. This did build. I hope. So I'll just pull over the image, Beaglebone, core image, Beaglebone. No, I think now something went wrong. Let's see, because this really seems to be like too small. Mm, let's just put bake the clean state core image. Minimal. No, it actually does not seem suspicious. Cengiz? I apologize. No, it's okay because a distro file is meant to define a couple of variables, saying the distro name, distro revision, or whatever. And these are all things that I didn't do. We're basically building no distro. This is intentional. Just just with systemd swapped in for sys5 init. So this is actually fine. This is meant as a demonstration that the machine really shouldn't rely on any magic in the distro. So we're basically building without the distro and just requesting systemd. And hi Mark. Um, Hi Mark. Skull. So this is rebuilding the the image right now. For in other news, again, please follow us on Twitch, make us famous. Mark, we've had a request for glitter sticker emotes. It's emotes or emojis? Whatever. So we really have to try and be famous so we can give our community glitter sticker emotes. So my image build is still churning, doing funny things. Tar, wake, whatever. Um, this differences between images and distros. Yeah, that's a classic. I say, please, for a more in-depth explanation, look at the last or the one before the last sessions I did. It was exactly on machine versus distro versus image, but basically it's like distro is it defines the ABI of your distribution, and image defines what goes into the image. We've had the same question in Lyon on the Yocto Project Summit, and I've come up with a explanation that you can even go and hand out in primary school. Think of it as the distribution defining what you are building with, like you're using Lego bricks or Fischer Technic or whatever construction mechanic kit you loved as a kid, and image is like what you want to build with it. Do you want to build a racing car, a crane, a boat, a plane, whatever? So the one is like it defines how the building parts look like. In case of Lego, it's all the like holes in the lower end and the nibbles at the upper end, so you can stick things together. And for Fischer Technique, it's like nuts and bolts, and for some other, it's screws and metal things. So this is the ABI, the building interface you can use to put all the building parts. In the case of Yocto, it's the recipes and the packages together, and the image is like what all of those things you want to make up your thing. I hope that makes sense. Time for more drinking, and then we gotta flash the board. So here we go. Is my image ready? My image is that's why I'm confused. Small trick. That was just giving me the thinking. If you're building for Pocky, then distro sets a couple of things, including the libc in use specifically, which means that everything that we do ends up at temp. In the case of a no distro build, I have no particular idea why it is. Mark or Richard, Richard, I know you're listening. This is your 15 minutes of fame. Please explain, okay? In the case of no distro, we are ending up at temp dash distro libc in use. We could have set a muscle too, but in the default is glibc. So whatever we did right now ended up in temp glibc. Temp glibc deploy images the Beaglebone. Hooray! Here is the things that I actually wanted to see. Core image minimal, yada yada yada, yada yada more yada, yada WIC XC. Okay, and you can see now this is already a little bit bigger, like double the size. 6.5 versus 13 max, but seriously, like 13 max is still not big and not exactly huge. Mark, can you please check the link if that's right? Thank you. So this is the image we want to get. Let me just pull it over. Temp glibc deploy images Beaglebone core image minimal yada 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 more yada WIC. Okay, and then fun. Streaming to you guys makes my CPU overheat, so I'm throttling. XCCAT core image minimal. 15 def SDA. XCCAT something. I'll give that a try later, okay? Seriously, thank you. It's always cool if you have like some magic incantations you can use to impress people. Even more so at work. Makes you look like the uber crack. Okay, sync. Here comes my image. Again, plugging it in. Let's see what happens. No distro 0, and this already looks pretty much like systemd. A lot of really cool stuff going on there, and everything's okay. So I guess yeah, you can see the kernel was already built when I did my preparations on Monday. Now you can see it kind of like the image got a little bit bigger. 37 versus 10 max. I happen to know that this is quite a bit due to the UDEF hardware DB, but in the end, this is still quite okay. And we can also look at etc OS release, and you can see that I did basically just set my distribution to be called Tinker and no magic beyond that. Leonard would be pleased. Maybe. Um, I don't. I usually don't take part in the usual flame wars. System D has use cases. System 5 has use cases. Use whatever fits your bill. There's no evangelism here. This is probably the one thing you should always take away from things that I explain. Whatever I explain, make sure that it fits your bill. I mean, you're usually not getting paid to use the most shiny or the most fancy tool. You're getting paid to get your work done. And um, and if systemd fits your use case and makes your work easier and helps you get your stuff done and getting paid, then use it. And if it doesn't fit your bill, then don't use it. Okay? Same holds true for Yocto. I appreciate that all of you are like watching this and giving me feedback and whatever. This is awesome. But if you ever run into a project where you think like, oh, this is really hard with Yocto and it would be so easy with Debian, for God's sake, use Debian. Okay? This is I'm not getting a single dollar of telling you that Yocto is awesome. I'm telling you that like what Yocto can do, so you can judge for yourself when you want to use it. Use it when it really makes your life easier. That's what technology is all about. It's not about using it just because it is technology. It's about using it because it helps you. Okay? That's the point. So, last thing I promised, we'll have a small look at WIC. WIC, as I already explained, is the Open Embedded Image Creator, and it comes from the requirement that during that Open Embedded by itself creates only the root file system and all the things that are inside it. Then we had ImageFS types that basically just took the root file system and like put it into a tarball, put it into a file system, put it into some binary form, compressed it or whatever, but did not actually like work on the contents of it. But more and more boards require the image that they use to boot to have a specific form, to have specific partitions with specific things being on specific partitions. And so we came up with WIC, or not we, especially not me, seriously. So if anybody of you wants to throw money, throw it at the Yocto project, okay? That because put your money where your mouth is. If you put money into the Yocto project, then it will help us give you a better software, less bugs, more testing, more features. So throw money, okay? Or throw beer. That's my direction then. So WIC. We want to look at WIC. WIC comes in the form of scripts that like take specific parts of an image, or yeah, I think that's okay. That take specific parts and pour it into a form that suits a specific board. In case of ARM, this is usually like a small fat partition with U-boot or the first stage bootloader in it. Sometimes even sometimes also the kernel, sometimes not. It really depends on the project in question, and the bigger partition where the root file system is located. In the case of x86, it is usually something like FE, where you have also a VFAT partition that fulfills specific requirements. You often have a swap partition too, but in the end, it's like take the root file system that comes from the Yocto from the build process, do some partitioning, binary formatting magic on it, and pull it out as a blob that you can put on your target directly. We will look at a couple of examples here, because there's a couple of WIC scripts included in Pocky. Those are called the canned scripts, the canned WIC kickstart scripts. You can see this here in the path. Pocky scripts lib WIC canned WICs, and we have to work on the naming serially. And you can already see, yeah, this brings like support for FEDisk hybrid ISO to boot of a live CD, all those things. And there's basically two ways to use WIC. You can either use it manually, which I'll just give you a small peek but not do, and you can use it like implicitly from the machine configuration, which is what we already did. So if you are in your development shell, which has source Pocky OE in it, whatever, then WIC is also a binary in your path already, and it tells us a lot of funny things, probably way too many funny things. I seriously don't intend to read all this. So we can do like WIC list images, and then we can see what images what image scripts are already present in our specific setup. In this case, what I already told you, generic x86 using an FEDisk image, creating an SD card image for an MPC A3. Yes, for those of you who are still working on PowerPC, this is awesome. I'm super sure. We can make something for QEMU RISC-V. This is for the fancy stuff, and hybrid ISO, everything. So I think one of the last things we gotta do now is look at some WIC scripts. Those are meant to be located at a canonical place in the BSP layer 2. Just like I told you about the about U-boot, usually meant to be in recipes.bsp, the kernel to be in recipes kernel. The WIC scripts have to be in, let's go into method.ti, let's have a look. Hopefully, or rather not, probably just doesn't need a specific WIC script. Conf machine, let's look at the Beaglebone again. Yeah, you see, SD image boot part WKS. This means the Beaglebone is fine to boot off a generic image where what? We gotta look this up. It just let me look this up. So we are at Cengiz says like WIC for NXP sucks. It would be very helpful. It sure is possible. Go kick somebody to make it up for you. Okay? It's all a question of somebody creating it or the BSP vendor handing it out. So it's absolutely not impossible. NXP, especially IMX6, has been notorious for the SD SD card images where they did a lot of arcane internal magic, mostly because they were already around before we had WIC. And the same goes for Meta Raspberry Pi. They also had some form of SD image that just because they needed something before WIC was already around for everybody to be used. And I really can't blame them for like going, hooray, there's WIC now, we gotta do everything again. But of course it would be great. So we gotta look at SD image boot part. That's what we wanted to do. Pocky scripts, no lip can't WIC, no WIC can't WKS SD image boot part. So we have just verified that the machine is using this particular WKS file, and now we gotta look it up, and it tells us quite a lot already. It tells us there are two partitions, number one, number two. It tells us the file system types. It tells us label and all the basically it's a lot of magic that actually goes into fdisk or parted to be more precise. But think of it as like scripted fdisk on steroids. Okay. Mark has a WKS file for the MX6. Awesome. Thank you very much, man. Give me a second. Okay. So, what did we want to do now? Actually, like this is what I wanted to tell you. Wanted to show you. I've streamed for an hour. I've had a beer. Any questions? Remarks? I know. I know I ignored a couple of questions because yeah, I tend to break things. Let's just have a look at one small thing. Often people wonder why things are being pulled into the images. This really does not like belong into this specific session, but uh, until somebody like brings up another question, remark, whatever, let's have a look at it. And before I go at this, really remember to follow us on Twitch, follow us on whatever social platform you want. Get in touch with us on the mailing list. Get in touch with us, especially on #Yocto on Freenode. There's always somebody around, especially during European and American work office times. Drop in, say hello, have questions, have remarks, send patches, and just hang around with us. Okay. I wanted to look at dependencies because in many cases, people wonder why things are being done in the way they are being done. So what we have is like bitbag core bitbag basically, and this gives us a dependency graph of something. Wrong terminal. Bitbag core image minimal. Hooray! Time for drinking. So it tells us we got a task dependencies dot. Oh, that's basically we got a task dependencies dot. That's the most important one. And what does this mean? Despite it being a dot file, really you don't want to open it in a dot view because it's just like gonna blow up and crash your machine. It's huge. Let's have a look, just so you get an impression. Task depends dot. 700 connections, this usually blows up every dot file viewer. But thankfully, dot files are really easy to expect to parse manually. So if we want to like find out what core image minimal directly needs to be done, here it is. You can see core image minimal being built directly requires these things to be done, which is already quite a lot. If you want the popular license directly depends on these things. And I guess I picked a rather bad example here. Can anybody just give me the shortcut for only giving out the like package depends dot? I thought it was included in dash G. Mark, Richard, anybody listening or not? Nobody? What about Toaster UI? Okay, I'll take this as the at the last question then before my beer is empty and I gotta head home. Toaster UI. Toaster has like two use cases, which I both personally do not use, and of which I only think of one as actually being worthwhile thinking of. Um, Toaster can be used as a like front end in image construction, adding layers, setting up your builds. Um, I seriously think that's a bad idea because it integrates really badly with all forms of CI/CD, which you usually want to. There's way better tools to really do this. I am we even I that this is a really a recurring questions. How do we make our or how do we manage our layers and setups for Yocto projects? And I actually have prepared a rather lengthy explanation on Stack Overflow just today. Here it is. Please chime in, comment, expand, tell me that I'm wrong. Bitbag GUDEX. Let's give it a try. Doesn't look like it. Okay, so in this case, I really recommend to not go for Toaster. As Mark already mentioned during the in the chat, Toaster has a secondary use as a build inspection tool, and there I think that's like a good thing. You can have your CI/CD pipeline cranking out all those builds, feeding the Toaster database, and then you can use Toaster as a shiny front end to actually like look into the history and inspect your builds, what's going on. And this is the use case I'm personally not using because I just don't need it, but where I think you should like go for it if that's what you need. And with that, I'll say like bye bye. Thanks for being with me for the repeat session. Sorry again for like being tricked by Wi-Fi on Tuesday. Everybody have a great weekend. Have lots of beer wherever you are. Um, Again, join us on Twitch, on IRC. Get in touch. Send us an email or just throw glitter stickers, okay? So, bye folks.